Hello students, I am Neeru, TGT Science from GGMS Kamal. Today, we are going to study our chapter from class 9th, Is the Matter Around Us Pure? So, let's begin with the topics we are going to take. The topics we are going to take are what is a mixture? Then, second topic we are going to learn is types of mixture. Then, what is solution? What is how to find out concentration of solution, what is suspension, and what is colloidal solution. So, these are the main learning objectives of this video. Let's proceed. See, in this first slide, I have made clear that what is a mixture. So, mixture is made up of two or more elements or compounds mixed in any particular ratio or proportion. Actually, what we find in around us, it's not pure always. What we call pure is not pure actually. They are mixture of certain things. Like here I've given two examples also of mixture. What is sugar solution? So it contains water and sugar. And even sugar itself is mixture. So other mixture is sugar and sand. So this mixture has many components. In this way, we can say that mixture is something where two or more elements or compounds, here I am highlighting the word elements and compounds. So it can be made from one or two or more elements. See, two or more elements here means that they are mixed in a fixed ratio or proportion. So again, mixtures are of two types. Let's proceed. They are homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures have uniform composition. That is, they are they are just uniform in their composition. That is, all the elements are same here. Like we can see the example is sugar solution is the example of homogeneous mixture where all elements are equally distributed and there are no visible boundaries of separation. That is, you can't see sugar and water separately, or you can not see any other thing in a sugar or in water solution. So this is homogeneous mixture. In the same way, sugar, salt and water mixture, salt solution, you can say, is also an example of homogeneous mixture. Whereas heterogeneous mixtures are different. As the name suggests, heterogeneous, that is, it does not have any uniform composition. You can see various elements very clearly with your naked eye also, like sugar and sand solution. You can see both the things, both the components very clearly here. So these are two types of mixture. Then coming to solution. What is solution? Solution is mixing two things. That is mixture of two things actually. That is solute and solvent. The solute part in the solution is usually considered to be the one which is less in amount and solvent is more in amount. So it is a homogeneous mixture of two or more substances. It has two parts, solute and solvent. A substance which is dissolved is solvent. Like in a sugar solution or salt solution, sugar and salt are solute, whereas water is here solvent. That is a liquid part of solution in which substance is dissolved. That is, called solvent. Here in sugar solution, water is solvent, but solvent, it is not necessary. They are always liquid. They can be solid or gas also. Then here we have types of solution. Types of solution, if it is aqueous solution, one of the major solvent is water. Aqua means so water, like salt and water solution is aqueous solution, whereas non-aqueous solution doesn't have water. Here we can take example of sulfur and carbon disulfide. It is non-aqueous solution. Then coming to next point is what true solution. True solution is like homogeneous solution we have studied. The sugar and water solution is true solution. Then coming to next is saturated solution. Here we can say saturation point has to be achieved. Saturation point, like if we keep on adding sugar in water, at one point more sugar won't be dissolved in it. That is the saturation point, and that solution we call saturated solution. And unsaturated solution, like if we heat that solution of sugar and water, then more of solute can be added to it. That is unsaturated solution. Now we can also find concentration of solution. Like what is the concentration of our solution? We can take the amount of solute divided by amount of solvent multiplied by 100. In this way, we can also find our the concentration of solution. What is the concentration of solution? Now, if we move to our next slide, it tells us about suspension and colloidal solution. Suspension. Suspension is usually where solute particles are visible, like sand and water mixture. So after placing it for some time, solute particles will settle down, like sand will settle down at the bottom. And still we can see some minute particles also above, that is in water also. So where solute particles settle down, it is called suspension. It shows no Tyndall effect. Tyndall effect is spreading of light. Like if we will show, if we will make torch point towards that solution, it will not spread it because the solution here is bit translucent type of solution, and particles are not evenly distributed, so it will not show Tyndall effect. Tyndall was scientist on which this effect was named. Another is colloidal solution. In colloidal solution, you can't see solute particles with your naked eyes, like milk. You can't see different particles of milk with your naked eye. And here also, although solution is translucent, but since the particles are evenly distributed and these particles not even settle down on their own, we haven't seen any particle settling down at the bottom of our beaker or container in milk. So this will show Tyndall effect. That is, light will disperse here. So this is called colloidal solution. Now we can take one example also, how to find the concentration of solution. As in earlier slide I have mentioned, we can find out using the amount of solute and amount of solution multiplied by 100. So let's find out how to find out concentration of solution. See here I have taken one example from your textbook only. To make a saturated solution, 36 grams of sodium chloride is dissolved in 100 grams of water at 293 Kelvin. Find its concentration at this temperature. So, here mass of solute is 36 grams, mass of solvent is 100 grams. So, complete mass of solution will be mass of solute plus mass of solvent, that is 136 grams. So, mass of solute is 36, mass of solvent is 136 grams multiplied by 100. So, our answer comes 26.47%. So, in this way, we can find out concentration of our solution also in a very easy way. I hope you have understood the topics very clearly, and I would welcome your suggestions and regarding this. If you have any doubts, you can ask me. Thank you very much.